In December 1959, 5 years before he was to get his Nobel Prize, Richard Feynman gave a talk at Caltech entitled, "There's Plenty of Room at the Bottom." The talk is often cited as the beginnings of nanoscience, the study and manipulation of matter at the scale of nanometers, 1/1000th of a meter, or 100,000 times less than the thickness of a human hair. Or as Feynman put it, a staggeringly small world that is down below. He was especially fascinated by biology, years before the insights into cellular mechanisms that we have today. Cells can do all sorts of marvelous things, all on a very small scale, he said. Consider the possibility that we too can make a thing very small which does what we want. Today it's almost commonplace to view the cell as a miniature factory containing a large number of dedicated molecular machines. And the idea that we can learn from these machines drives the burgeoning field of bio-nanoscience and technology. The cell's motors are especially intriguing, whether they are linear motors walking along the cell's internal pathways while hauling freight, or rotary motors like those that spin a bacterium's flagellae at speeds of up to 100 RPM. The promise is for man-made biomotors with as yet unimagined applications in medicine, sensors, electronics, or engineering. Biology and medical research have already benefited hugely from near nanoscale technologies, as in gene chips able to rapidly scan genomes, or microarrays identifying new drug candidates. These technologies are constantly being made yet smaller, faster, and more efficient. And they're being joined by new truly nanoscale devices such as those that are able to manipulate the flow of minute drops of fluids, shown in these videos slowed down some 2,000 times, through what are in essence liquid circuit boards for use in medical research. Speaking of circuit boards, Feynman lived in an era, as he put it himself, when computing machines fill rooms. Speculating on what computers could do if they could be made much more complicated, he asked, why can't we make them very small, make them of little wires, little elements, and by little, I mean little. We've been making them littler ever since, of course, and so far computer chips have shrunk on schedule with Moore's law, the prediction of Intel founder Gordon Moore that the number of transistors on a chip would double every 2 years. Intel's recent announcement of transistors just 45 nanometers across, small enough that 30,000 would fit on the head of a pin, means that the law remains secure through the next few years. But beyond that, new technologies are going to be needed, and they are a major focus of nanotechnology. Many researchers are pinning their hopes on carbon nanotubes, sheets of carbon atoms rolled up like straws. These tubes are ideal for building tiny circuits because they can be made to be either conductors or semiconductors. A little over a nanometer in diameter, they make structures on conventional chips look huge. The nanotubes can be manipulated to create junctions and even formed into transistors. Another innovative approach employs a molecular switch that's like a ring sliding on a barbell. Its two positions corresponding to the zeros and ones used to store data on a computer. Combined with a dense array of nanowires, the switch has been used to build an experimental memory chip with some 100 billion bits of information crammed into 1 square centimeter, enough to satisfy Moore's law through the year 2020. Beyond that, well, again, Richard Feynman pointed ahead, suggesting in 1982 that one day computers could exploit quantum mechanics, replacing the bits used by today's computers with quantum bits or qubits to create machines with computational powers we can't even imagine today. It would have appealed to Feynman to hear that the spin of a single electron was recently turned into an active qubit. Back in his original 1959 talk, Feynman also envisioned tiny machines, asking, why can't we drill holes, cut things, solder things, stamp things out, mold different shapes, all at an infinitesimal level? Today, such infinitesimal machines exist. For now, they're being used mainly to give demonstration fairground rides to tiny insects, but these nanomachines might someday be assembled, or even assemble themselves, into nanorobots. Feynman himself, quoting a doctor friend, said, "It would be interesting in surgery if you could swallow the surgeon," anticipating the notion of nanorobots that cruise the body, cleaning up arterial plaque or rewiring brain cells as they go. As Feynman said, it was a very wild idea, and it remains only a very wild idea today. But as he also said at the outset of his talk, "I would like to describe a field in which an enormous amount can be done, and with an enormous number of technical applications." Almost 50 years after they were spoken, those words are truer than ever.